Welcome back to the fabrication lab. We're going to do some more things tool-wise today, same as Wednesday. I do want to just mention, though, first of all, that you are being recorded. I have to record one lesson a day so that if somebody missed out, we can have a backup copy, and a student that's absent can find out what we did that day. So you're being recorded. However, don't do anything that you shouldn't do. But I do have to give you that. I do have to give you that message or that warning, or the privacy policy lets you know that that's happening. There's a good chance you're being recorded lots of times when you don't even know it, even out in public. So just be good all the time. Don't do anything bad, and you're covered. Okay. So what do we got going on for today? Today is going to be more tool talk. Just like Wednesday, what I want you to do is follow along with the discussion, watch the demonstration, ask questions. I'm going to ask you guys some questions. I want you guys to give me some back and forth, and I want you guys to let me know if I ask a question, you tell me what you think, or maybe just a little review, you tell me what you know. Okay, so that's what today's going to look like. You're going to take notes. 10 good notes is a good start, right? I'll help you out. If I think of something that's really important, I'll either say, write this down, like I told Feldman last time. He was paying attention real good, and I let him know every time something was coming up. Or if I spell something out for you guys, that's also a good clue. If I spell out a word, that probably means it's something that you should write down. All right, so what we'll do is we'll take a quick review of some things we did last time. All right. So, did somebody do the spotlight thing? That's new to me. Somebody helping me out here? I see that I'm spotlighted. Who can tell me what that's all about? All right, nobody wants to admit it. They turned it off.
I have no clue what that is.
Okay. Well, we'll figure it out. Hey, we got others joining us. Hello, juniors. All right. So sophomores on one side, juniors on the other. I'm going to try to scoot you guys together. Awesome. No, let's leave the spotlight on. I don't know what it is, but it sounds interesting, so leave it alone. Okay, here's what we're going to do. A real quick review, and then back to so a few things new. I know we're short on time, so we're going to roll quickly through this. I know you guys can handle it. Just let's go through these quickly. What was this again?
Common twist bit.
Common twist bit, right. Okay, good. General purpose, just metal, wood, plastic. Usually comes in a convenient organizing index. I have all the sizes in there and labeled. I know where each one goes. General purpose bit. Okay, very good. How about this one? To my juniors,
I'll let someone else take it.
Paddle bit.
Paddle bit.
Good. I hear some people saying paddle bit or spade bit, either one. This is a great choice for wood only. Doesn't do metal. It does do wood very well. It just does it really rough though. Okay. It's fast, but rough. You won't get a nice clean edge with a paddle bit, but if you're just trying to drill through a 2x4 to put a wire through it in construction, it does a great job. Economical because they're very low cost to manufacture. You can get a set pretty easily. How about this one? Anybody remember this one? For the
Forstner
juniors?
bit.
Forstner bit. I've heard a couple people say Forstner bit. Good. Forstner bit. Give me a recap. Metal
It's
or
like
wood?
this wood. It's like the paddle bit, but it's more precise.
Right.
Expensive.
Very good. For wood only, like a paddle bit, but more precise. Smoother finish, cleaner edges. All right. How about this one? I'll show the juniors first.
Step bit.
Step bit.
Step bit, good. A few people said step bit. Fantastic. Tell me about a step bit. Shallow cuts in metal. Thank you from the junior group. Shallow cuts, metal only, and only in thin materials, right? For sheet metal, basically.
The deeper you drill, the bigger the hole.
Right, very good. The deeper you go, the bigger the hole. Each step indicates a bigger diameter. Very good. Last one, it's not really a drill at all, but I can use it to make holes. Hole saw, awesome, hole saw. With the hole saw, don't forget, I need another piece. Anybody remember what that attachment piece is?
Arbor.
Arbor, thank you. The arbor screws into the hole saw. I need a whole bunch of these, like different sizes. I only need one of these. Screws in there. It gives me a place to attach the drill, and it gives me a place to center it so that I can get it right in the right place. Now, very good review. Thank you guys for everybody for participating. That went really quickly, which leads me into this. Remember the arbor. Here's the new thing for the day. Bailey Feldman, if you got your pen ready, I want you to write down the word shank. S-H-A-N-K, shank. Right? That's this portion right here. This is the shank, is the part that gets attached to the other tool. So if I'm using a drill, this shank, that's the part that fits into the chuck, okay? If I have a regular twist drill, that's also called a shank. If I have a Forstner bit, that part's called a shank. I don't want to go too far ahead, but also everybody probably remembers the jigsaw. Maybe you've seen a jigsaw before. The blade for a jigsaw, the part where you attach the blade to the jigsaw, is called a, you guessed it, shank, okay? So remember shank, S-H-A-N-K. All right. Now, while we're talking about shank, I want to show you something. Another class member from a different class yesterday, they were doing the exercise, and they found a picture of a drill bit while they were researching. They said, Heartline, here's a drill bit. You never showed us this one. And they showed me a picture of this. It showed me a stock photograph. Anybody know what this one is? I did not show you this.
That looks like a variation of a twist bit with like a pilot on the end of it or something.
Yep, very good. This is called an auger bit. If you're writing things down, it's A-U-G-E-R, A-U-G-E-R, auger bit. Okay, the reason I didn't show you this, all those other things are readily available here in the fabrication lab. When the student brought this one up, I said, yeah, I didn't think of that one because we don't have those in the fabrication lab. Let me be clear, guys. I can't show you every single drill bit that we have out there. What I try to give you is a little bit of variety of what we have here. But there certainly are many, 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 many different ways to drill a hole and many different variations. So this is one of those variations. As Brewer said, it looks kind of like a twist drill, but different. All right, this auger bit has a specific purpose, and here's a little short fat one, and I got a longer, narrower one. These are more, think about big timber, all right? So you're outdoors, you're working with telephone poles, landscaping timbers, you're building a retaining wall or a garden outside of a garden, or landscaping, something with big, big timber, right? 6x6s, 8x8s, telephone poles, whatever. This is the tool for that, okay? Now, anybody remember what those grooves are called on here? The spiral grooves on the drill bit? Flutes, good. Several people saying flutes, okay? Look at the flutes on this dude. Man, those are some big honking flutes, right? So this one actually can carry away a lot of material and makes it go a lot faster and a lot easier, right? So big flutes, one thing different. What else about this? I'm going to point this to the sophomores, and I'm going to go over the juniors. Look right up here. All right, juniors, look up here on the top. Anybody notice anything about the point? Remember the paddle bit or the spade bit sort of had a little centering point like that?
The point on the auger bit is spiraled like it's threaded.
Yep, you got it. Good job, Brewer. That has a threaded bit like a screw. That is called, if you're writing things down, that's called self-feeding, okay? The purpose of that little screw on there is to help you to get through the material, okay? So I'm drilling in here. That little screw is actually, it's going to pull itself into the wood. So you don't have to push as hard. It's actually screwing into that wood, and it's pulling itself in. So self-feeding bit, that screw is going to make your job a little bit easier. Now, you're going to need an easier time with this because this guy requires a lot more oomph, right? So This probably, another reason why we don't have these in the fabrication line, this DeWalt 20-volt drill is probably not big enough. You're going to think about one of those bigger corded drills, maybe the kind with 2 handles on it, side by side, and it's going to take a lot of effort to hold that drill. It's going to want to twist your arms off, right? But again, think about the job it's doing, outdoors, big timber. You're going to need that power, but it's the right choice for that. So that's the auger bit, a couple of different features on it, a couple of applications for you.
How do you spell it?
Auger, A-U-G-E-R, auger. Auger. Anyway, that's just to reiterate many different kinds of drill bits, and we've highlighted a few that we have here, but be aware there's going to be more variations and other things. And keep that in mind when you're out there looking in your job, when you get to that career one day, that this is a starting point, but do your good research and find them. Okay, let's move on. Any questions on any of that? Okay, good. Now let's move on. So last time we talked quite at length about the drill and all the drill bits, and we just reviewed all those drill bits. We started into the impact, and we talked about what are the features that are the same. Remember, same battery, same pistol grip, same trigger, same motor on top, right? Where did it change? What got different here? What did we say? Oh, what's different?
The truck.
Yeah, the chuck, right? The chuck. The chuck and how we attach the bits. Thanks. Becker, I heard your reply. I see a couple of replies over here on sophomores. Thank you guys for chiming in. I really love the participation. So this impact driver, it has something different. It only, where this, remember the drill had that spinning chuck and I could loosen or tighten and those fingers would close in or open, and I could get any size diameter drill bit in there that I wanted. This guy is different, okay? This chuck can only accept, here, let me scoot you guys a little closer. This can only accept a shank. Remember we talked about shank? This can only accept a 1/4 inch hex shank. I'll show it to you guys. A 1/4 inch hex shank. That's all that'll fit in here. If I try to put a round driver bit, it won't fit, all right? Or if I tried to put this bigger hex shanks, pardon me, this won't fit in there. Has to be a 1/4 inch, which is that size flat to flat. So from one side to the other. So the dimension, if I were to put a dial caliper on there and measure it, it'd be 0.25, 1/4 inch. And it has to be a hex shape. Now, pops right in there. That's wonderful, right? Easy to install. Goes right in there. It's locked in there. And then to take it back out, watch this. I just, instead of turning the collar, I take my fingers, I squeeze my thumb and my index finger. I squeeze and I pull away from the drill. I'm pulling against the spring and the bit comes right out, okay? Easy to insert, easy to take back out. Now, if you're curious about what's happening inside there, I want you to look closely. On this hex shank, there's a little groove. Show you guys, there's a little groove right there, okay? What's happening inside this chuck, there are a couple little ball bearings, okay? The ball bearings are under a spring pressure, right? So they're trying to be closed together. My fingertips are representing the ball bearings. When I push this in here, it slides those ball bearings open, and then they fall down into that little groove, and they lock in there, okay? That's holding the bit in. What I'm doing when I pull on that little collar is I'm releasing the springs so the ball bearings aren't pushing anymore, and I can pop it right back out. Okay, you don't really need to know that, but that's what's going on when I snap it in there and I pull it back out. Okay, so I said they all take a 1/4 inch hex shank. Now, that's the business end that goes into the tool. The other end is what mates to the fastener. Okay, so you guys probably have all seen this one before, right? Show you guys over there. Anybody know the name of this one? You better. Starts with a P. Cross tip.
I don't know.
Phillips. Maybe you couldn't see it that well. Sorry. It's a Phillips. You guys probably knew that. You might not have been able to see it. Thank you, No Hardy. You got it. Phillips, if you didn't know, come in different sizes. So I got 3. These are just hand screwdrivers, not for an impact, but for a demonstration. I've got 3 screwdrivers here. They're all Phillips, but they're all different sizes. Do you guys know how we tell the difference? How we name them?
1, 2, and 3.
1, 2, and 3. Thank you. Yes, that's right. This smallest one is a 1. The medium one's a 2. There's a number 3. These aren't all. Pretty sure there's a number 4 that's even bigger. Not very common. And then if you guys have eyeglasses or those really tiny little screws, there's a 0 and a 00, I think, 00. So there are other Phillips, but the reason that we name them is so we know the difference. Yes. So anyway, keep that in mind if you're trying to drive a Phillips screw, either with a screwdriver or with one of these bits for the impact driver, that if it's not fitting just right, you probably have the wrong driver. So maybe go up or down one and see if it fits better. Okay, there's this old standby. Anyone know this one?
Flathead.
Flathead, flat tip, slotted, lots of different names. Slotted, flat tip, flathead. Good, I see lots of people saying that. Thank you. This one, you know, this came way before manufacturing, mass production, before the Iron Age, because the craftsmen made their own screws. And it was easier just to make a slot than try to make some complex geometry like a Phillips head. However, if you've ever used one of these, somebody tell me what's the problem with a flathead.
They slip off the screw.
Slides around.
They slide around and slip off like crazy, right? Really hard to keep it centered, especially as it gets tighter, right? It always wants to slip out, okay? So, we made improvements, and a guy came along and invented this cross tip, or Phillips. And anybody know offhand who made the Phillips screw?
Phillip.
Yeah, so that's a good guess, but it's a trick question because I thought I might be able to get you. Not Phillips, not at all. The man's name that invented this is Thompson, okay? Now let me tell you, Thompson, he was a good inventor, but a terrible salesman. So along comes this guy named Phillips, and I think they are having a conversation. There might even been a little bit of debt in there, so Thompson owed some money to Phillips or whatever, and they squared up and said, well, you just take the screw and be running. So Phillips, he's not a very good inventor, but he's a great salesman. He realizes that that slotted screwdriver doesn't fit very well and it slips off. Also, same time, Henry Ford comes along and he's building automobiles on the assembly line, right? So no more just slapping pieces of car one at a time, putting it on, then one, then the next, right? Now they're moving down the line, people putting things on all at the same time. This guy's putting the tires on. Well, they needed a faster way to put the screws in, right? And that slotted screwdriver just wasn't getting it. Phillips went to Ford and he said, hey, I've got this great invention. And he said, it's called the Phillips screw. I named it after myself. It's sort of egotistical, I guess. He said, when this thing gets close, because that Phillips has a point on it, sort of just engages and grabs a hold. He said, so if you're using an automated drill or a tool, an automated tool, I should say, he said, it's going to speed up your assembly time. So they bought it, Phillips screw, great, right? On goes the story. However, the same feature that makes that thing slide in there easily and engage also allows it to cam out or to slip, right? And if you guys have seen that before, that Phillips screwdriver, if it's not properly aligned or you're not got enough pressure in there, it'll strip and it'll slip, right? It makes a horrible noise and it ruins the bit or ruins the head of the screw. So we make another advancement in technology. Does anybody know the name of that one?
Hex
Star.
Torx.
Okay, very good. I heard star, which is star is kind of a generic name. It looks like a 6-pointed star. Many people call it that. I also heard somebody say Torx, and that's the proper trade name is Torx. Now, if you're writing this down, it's not Torques, like a twisting force Torx. It's Torx, Torx, all right? Torx. And the Torx was an improvement in that it didn't slip out as easily. And my personal favorite
It's my favorite.
he likes it too. So we both like it. So if the two of us like it, you have to like it. But anyway, I think it's a lot easier. It doesn't slip out as much. It's a little easier to engage, and especially for a new user, right? Okay, so let me warn you though. Just like I told you, there are 3 sizes of Phillips, maybe even more. There's a bunch of sizes, 3 common ones. Torx is worse, okay? Torx has a bunch more sizes. Now, I just brought these to you as an example. These are obviously hand wrenches that you would use, like an Allen, but these actually have a Torx head. And the reason I wanted to bring that up to you is I want you to see, this isn't even a complete set. This is just a few of them, but it starts out with a T9, 10, T15. So when we name Torx screws, we name them with the letter T and then a number. Smaller numbers are smaller in size. As the number gets bigger, they get bigger. So if you want to see what we have here, this is going to be the most common one in this fabrication lab, maybe in construction industry as well. T25, very popular, okay? So we also have T15, and I'll just pop one up here to show you. Here's kind of the difference. You can see they both have a star shape inset, but the one is definitely bigger than the other, okay? So a T25 and a T15 are common around here. If you guys do any automobile work, lots of front brake calipers on your automobiles or trucks now are also Torx screws, and they're even bigger. They're like T50, T55, T75. So Torx comes in a bunch of different sizes. The importance of this is that when you're in here working, or when you're on a job site or in your career, just be sure that you get the right Torx bit. That's not the right one. The right Torx bit for the right screw. Okay, they have to be a good match. If you don't have a good match, they're either not going to fit at all, or what I mentioned before, it's going to strip out, prematurely wear out the tool, or damage the screw. All right, so how do you know? Well, the manufacturers, they thought about this, and they said, well, we got to help these guys out just so they know. These all have a little imprint on them. You can see this. Might be hard to see. If you can't see it, trust me. It says T15 on it right there. Hold it up for the juniors too. It's stamped on there, T15, so most of your driving bits will have the number on it. And the screws have that as well. So right there you can see this is T15. Show for you guys. T15, okay? Likewise, my big T25s, right there on the package, right there. T25. T25, okay? So just make sure you match up the screw with the proper driving bit. All right. We're doing pretty good on time. That's good. All right, we covered Phillips. We covered Torx. We covered how you identify those Torx. By the way, if you get a Phillips bit, it should say P1, P2, P3 on it. That screwdriver I showed you, right there, you see it says number 2 right on it. Number 2 right on the handle. So look, do yourself a favor. When you pick up that tool or you pick up that bit, just look for that little number. Make sure you're in the right ballpark. All right. Let's do another one. This one is not as common. You might see it here in the fabrication lab, but I don't think we have any. Again, you might see it in your career or at home. Does anyone see that one there? See that shape? It's just an ordinary square, guys. So it's kind of like in between a Phillips and a Torx. It was one of those intermediate ones. It was used on decking screws a lot for a while. I don't think it's as popular anymore. Just a different version of it. Okay. So you'll see that one square. It also goes by its trade name sometimes. Anybody know the trade name for, or the inventor name for the square drive, square bit? Okay, that one's actually also John Square. No, Robertson. You may hear the square drive called Robertson drive. And I don't have any funny story for that one. I'm sorry, I don't know the history on that one. I'm just going to guess that one actually was invented by a guy named Robertson. But maybe there's a long story with that one too. But anyway, on to the next one. Here's one that looks like a ordinary hex. This is actually kind of neat. It has a Phillips head, but more accurately on the outside is a hex head, right? Like a regular bolt that you might put a wrench on or a socket. So we have a corresponding socket to go with that. So this little bit here is going to fit together on the outside rather than the inside. And the neat thing about this one, looky there, it's not magic, it's a magnet. So inside there is a little tiny magnet, and it holds the screw for me. So you won't see this hex head much in woodworking, more for sheet metal, okay? So they got a little more driving force. And if there's anybody out there on a farm or industrial site, these hex head screws are common for sheet metal roofs. So if you have a barn or a shed or you see an industrial building that has a metal roof, oftentimes you'll see these hex head screws. The wonderful thing there is,
I just did a sheet metal roof at my house building a shed, and that's what I used. But it also had a little rubber washer on there.
yep, good point. Underneath a little rubber washer under the head helps to seal it, seal out the water. But that magnet comes in handy because you're up on the roof and you got a bag full of screws on your hip or a little bucket, and you're out there trying to put these screws in. That magnet will hold it in there so that screw doesn't fall out. So that's a nice feature about that. All right, moving on. Now, you saw me a minute ago, and I showed you that little T15. That's a little short guy right there. So I shouldn't use gender. It's a little short one, guy or girl. It's a little short bit. Okay? Now, I want you to notice that that one does not have that little groove, that retaining groove. So when I try to put that one in here into that impact driver, it will fit, but there's nothing to hold it in. It slips right back out, and it could even fall out on its own. So this one you can't use all by itself with the impact driver. Okay? We have this. It's just a little extension. This extension has that proper groove on there. So the extension does lock in there properly. Okay, it's locked in there. And then this little bit right here, the small bit, it's just an economical, better choice, more cheaper, more inexpensive, I should say. It's a more inexpensive alternative. Remember I said these tips will wear out, okay? They get worn. You're putting the screw in, taking the screw out. Every time that metal on metal contact just wears away the surface a little bit. Over repeated use, these will wear out, okay? They'll get dull on the end or rounded, and they lose their effectiveness. So if you were having to use these a lot in your job or in your industry, and you wore them out frequently, when you rather, this one's going to be a lot more, this little red one's going to be a lot more economical than the longer one that has the groove cut in and everything else. So these you can usually buy a pack of 1 or 2 for the same price as maybe a pack of 5 of these. And these little short ones often come in packs of 10, 20, 25, okay? And they're made for somebody that's going to be going through a lot of them. But you remember, you just have to use that with the extension, okay? So if you see the little bits, just make sure you grab a little extension. Extension comes in different sizes. This is a pretty common size, like 2 or 3 inches. But if you really need more length, we can go up to like this one here. It also has that groove on the end. So the shank portion fits right in, locks in there, okay? But the other end is meant to accept that little short bit. So I put that little short, not that one, this one. Put that little short bit in there, and I've got it in there. Okay. So there's the story with the little difference between the little short one and the longer one. What kind of questions do we have this far?
How does it hold the small bit in there? How is it any more accepted than just the regular?
Oh, so that's a good question, Corinne. I don't know. I'm going to have to look that one up. There's basically It also has a spring. I don't know what's inside, but if you look closely, I can actually pull down on this little collar. Okay, I think it probably has something similar where it just has some fingers inside. They're not the little ball rounded ones that fit in the groove, but there's some kind of spring pressure. So when I pull that little collar down, I'll show you guys too. There is a little collar. That's good. I'm going to have to investigate that. I'm not sure. There's some kind of spring grabber, but it's a little bit different, I think, because it definitely doesn't have the groove. Excellent question. You are super paying attention. Let's see here. What else do we have? All right, here's one just like kind of for the history books. If you see these, just ignore them. This is a combination. It's a Phillips on one side and a slotted on the other. See, Phillips on one side. When the drivers first came out and everybody was using a screw gun or a drill or an automatic electric screwdriver, these were fantastic. Somebody said, hey, you can have a Phillips and a slotted in once, covers everything. And there usually you'd be a little place you can clip it on there. But the truth is, because it doesn't have that little collar on there, that little reduced groove, it's not going to fit in the impact driver. It's not going to stay in there. And that leaves you back with the drill. So you probably will see these around, but I'd say just ignore them. They're not very useful. Good for 10-in-1 screwdrivers.
I have seen them as like inserts into like a regular screwdriver before. That's a common thing I see with, yeah, like that.
Yep, another class asked about that. There's one little difference though. Most of the time these have to have, if you see right there, it's going to be hard to see, but there's a little ball detent on this one. So something has to hold that in there. But yes, good idea. If this is the proper one for a screwdriver, these are kind of handy. If you're limited on space or you're going to going somewhere where you have to carry your tools with you, this gives you all-in-one. Really didn't want to, or I didn't really plan to talk about that much because we're trying to do, but this is a good tool. You get the 4-in-1 or 6-in-1. So good point. You will see those in that. But these don't work very well in your impact driver, I guess is the point. Doesn't work with this very well. Good for other things though. Okay. We covered the hex bit. I'm looking across my table here, guys, to see what we have, guys and girls, to see what we've done and what we haven't done. Kind of refreshing myself here. Talked about the shank. I did want to show you. This is my plea to you guys, my request, if you will. Obviously, these things are little. These bits are small, right? They are very easy to lose. You could accidentally put it in your pocket. I'm not saying you did it on purpose, but you stick it in your pocket, you walk home, empty your pockets out, and then we never see it again. Again, not maliciously, but just accidentally. Or you drop it on the floor and it gets kicked under the bench. Or maybe it falls on the floor and we're sweeping up at the end of the day and it gets thrown away. These are like the heart of our little system here. If we were to lose all of these little bits, we'd be in big trouble because we couldn't use any of these impact drivers or tools for assembly. So help me out. Just treat these like they're valuable to me, to us, and just take care of them. So if you borrow one of these, if you take one out, make sure you keep a hold of it. Don't lose it, and make sure that when we're done, it gets back in our case, right? So obviously these things are hard to keep track of, so we put a case together here, and it just has compartments inside. And I know it's kind of difficult to see, but I basically labeled in here, someone labeled in here, T15, T20, T25, P2, P3, square, hex, place in the bottom for extensions. Try to make sure not only that they get back into this case, but make sure they get back into the right spot, please. That just helps all of us so that when we're getting ready to put something together, we can go right there and get that right bit, all right? That applies for all the tools. Take care of them, put them away. But just an extra plea, because these are small and easy to lose track of. And with a school system, it's not like I can just go ask Mr. Gels for 20 bucks every other week and say, hey, Mr. Gals, I need 20 bucks. We lost all our bits. He's going to say, you get money at one time a year, and we have to stock up then. So anyway, enough about that. Just please help me to keep track of them and take care of them. Okay. Woo! I am worn out. That was a lot. I think we covered a lot. I think we covered everything that I wanted to cover today. I want to just give you a little bit of a heads up. We're on a roll here. I love doing this part. We're trying to get as much tool education as we can so that when we get back in the building, hopefully soon, that we'll be ready, more ready to go right to work. So I'm pretty hopeful that Monday we'll get to this guy, this tool, jigsaw. Next up after that, circular saw. I do have some stuff to show you about geometry of saw blades. Just like we talked about the different kind of bits, there are many kinds of different saw blades, and why do you choose one with big teeth or small teeth or teeth that are crisscross, right? There's a whole bunch of stuff to talk about with that. So that's a little preview of what's going on. I do have one other thing I want to share. So I'm going to have to share with the sophomores and then point it toward the juniors. But take a look at this. Should be sharing. All right, Soph, tell me if you can see a slideshow.
Yes, we can.
Okay, fantastic. So the point of this is just to show you, like up in the upper left, all right, and sophomores, you're not gonna be able to see it real well, but you might be able to see the, look, you guys can see each other. All right, so sophomores, the idea here, or sorry, everybody, the idea here is that on the upper left there is most of the ones that we talked about, with the exception there's a posi driver there in the middle. That's a lot like a Phillips, but a little bit more different. They're not really interchangeable, so just be aware of that. The posi drive isn't really that common yet, but you'll see it more and more probably. So just be aware. It's the distinctive difference in that posi drive is, and I apologize, juniors, probably can't see this very well. The posi drive has more little points in the center. Another thing I want you to notice is this Torx with the little button in the middle. That's toward the middle of the page. That's tamper-proof or a security screw. Basically, some of these manufacturers got together and they said, you know what, we don't always want people to be able to take things apart. A case in point was many years ago, when the cable boxes first came out, people found a way to steal cable. They would actually open the cable box up, they'd flip a few little switches or move a wire, and they got free, quote, free extra channels. Well, it's really stealing it because they weren't paying for it. But the cable company got smart and they said, we're going to put these tamper-proof screws so that not everybody with a Torx wrench can take it apart, right? So the point of all that is, if you look in that lower right-hand corner, there are just a bunch of different tamper-proof or security screws. So this is just to familiarize you guys with it. You may have seen these on some kind of device that was meant to be tamper-proof. Some of these you might recognize if you go into a public restroom stall or something. Sometimes the walls on the stall, those middle walls will have those tamper-proof screws because I guess they don't want you to steal the walls in the public bathroom. But anyway, keep an eye out for that. You'll see some of these various on the lower right-hand corner here, some of those various screw types. And each of those are just going to be, just require a different driver, right? Some kind of different screw driver. All right, that was just for familiarization. You don't need to memorize any of those. Just be aware that there are dozens of different kinds of screw head types. All right, stop sharing. Come back to the main meeting. All right, guys, we are doing great on time. I'm going to wrap it up here. Are there any more questions? Brewer said Apple does the same thing with laptops to prevent people. Yeah, anyone that wants to protect their security of their product and they don't want you getting inside the average person. Obviously, that someone can buy those screwdrivers or those bits and so they can get to them. But anyway, you got a few minutes left. Proprietary technology. We'll talk about blades next time. Yes, good questions. I'm going to give you the last few minutes here to make sure that you can finish up your notes, upload those notes. If you wrote the notes on a piece of paper and you're going to take a picture, please, please, please make sure that I can read it. You guys make sure you get it right like that. Crop it down if you need to. If it's blurry and you can't read it, then I can't read it either. If you type your notes out, that's fine. I know some of you like to have an extra window open. You're typing while I'm talking, that's fine. Let me see those notes. That way it's a way that I can give you some points for attending today. And you guys get the familiarization by writing it down. It kind of reinforces it in your brains. So that's it. I'll stick around for a few minutes yet here for questions. Otherwise, we'll talk more on Monday. I hope to be back here on Monday. And this guy wants to say bye. Now listen, before you go, you got to turn on your camera, and I want to wave bye to you, and we're going to say your